Welcome to CK Physics. The topic is pressure, and the objective of this experiment is to determine how depth varies with pressure, or how pressure depends on depth. And I have water in a beaker. I have a trough that is going to help me trap any water. I have a container here, a can, on which I have holes at different levels. And what I'd like to do is pour water into this can, and for you to observe the strength of water jets that come out of this can. So I'll go right ahead and pour the water into the can. Please observe the strength of water jets coming out of the can. The more the water I pour in, the stronger the jets that will come out. What you notice is that the jet farthest down at the very bottom is the strongest, while the jet at the top is the weakest of them all. The reason you have the jet at the bottom being the strongest is because water depth here is the greatest. That tells you pressure will be increasing the further down you go. The deeper you go, the more the pressure. The jet right at the top is much weaker because the depth of water at that level is the weakest. You would want to understand also that if we keep depth the same, then pressure at that depth will actually be the same in all directions. That is known as Pascal's law. And I will demonstrate that using another can which has got holes drilled around it at the same level from the bottom. So I'll go right ahead and ask that you also observe the strength of the jets coming out. So as I fill it, water jets will come out of the bottom of this can, and these water jets are in all directions. If you observe in any one direction, the strength of the water jets is exactly the same. Perhaps what I could do is turn the can so you're able to see the can and jets from different angles. Whichever angle you look at it from, the strength of the jets is exactly the same, which tells you pressure in a liquid is transmitted equally in all directions, provided the depth is the same. That translates to Pascal's law, which states that when pressure is applied at any point in a liquid, it is transmitted equally in all directions. And we use that principle in a number of hydraulic devices. For example, the hydraulic jack, for example, the hydraulic press, for example, the hydraulic lift, or the hydraulic brakes. All those devices work on the basic principle established by Pascal, which we call Pascal's law. Remember, pressure in a liquid is transmitted equally in all directions. Thank you.